Hello and welcome to this tutorial video of how to draw circuits in LaTeX using the package CircuiTikZ. I am Shaptarshide. So before we go into the examples of how to make the circuits in CircuiTikZ, we have to get a quick idea of the elements, circuit elements, and how CircuiTikZ treats the circuit elements. So CircuiTikZ divides all the circuit elements into two classes. One is path style, other is node style components. Path style components are the bipolar ones. That is, as you can understand, path style means it can be in one path, in a path, while the node style, they do not exactly lie along a path. They just lie in the circuit, and we have to uh, take out the take out the specific outputs from the node style elements like op amp, transformer, etc. So we will see one example of both type of elements, how to use them. We will also need this manual for drawing circuits in circuits, but yeah, I will not ask you to read the whole manual. That's the point of making this video, that you do not have to read the manual, but you have to use it. You have to keep it handy. I will show you how to use the manual. So let us start how to draw circuit. Here's a new the take document. So we will start the usual way, the way we write any other LaTeX file. Sorry, document class article I will write. You can even use standalone if you want to have a separate some diagrams. The package that you will need is a package that we will need is CircuiTikZ. X is a X, the LaTeX drawing software. That drawing package is a subset of this CircuiTikZ. And some options we will use here. One is American, that actually dictates how the elements will look like. You can use European also, and SI unit. That's it. Now we start the document here. Now, how to start drawing a circuit? We have to draw it within the CircuiTikZ environment. This is the CircuiTikZ environment. Here we have to draw. Now the basic structure to draw a circuit is, it will start with draw, end with semicolon, and in between we will write. Okay, and all the drawings go using coordinate systems. Here we will first see as a path style component example how to draw an RLC circuit. Okay, so what we will do is we will start from the origin. So 0 0, this is the standard notation of any coordinate in TICS, the Cartesian coordinate 0 comma 0. So from here it starts. Then the element is written like this. We have to write 2, then within square brackets we have to write the element name. What is the element name? Source. Okay, I will draw it in a vertical fashion. So the x coordinate will remain same, and the y coordinate is the 5, and then I run this. So this is the standard structure of how to draw an element in CircuiTikZ. It will start from some point, then these two will be there with the square bracket, the name of the element, and the end point. So you can see the voltage source has been created, but you see it is inverted. By default it is inverted in CircuiTikZ, so we have to invert this. So in this square bracket itself we can write the other options for it. So I write invert and run it again. So now it's okay, right? Now here I will draw resistance, inductance, capacitor, and close the circuit. So we are now here at 0.5, this point. So from here I will draw the resistance means I have to simply write an R. And now say I give it 5 more points, so the ending coordinate will be 5 5. Again I draw, say, an inductor. I give it 5 more points, so now it becomes, as you can see, the x coordinate is increasing every time by 5, while the y coordinate is same. Let me compile it once. Understand? Right. So when I put r between 0, 5 and 5, 5, what it will do is it will put r exactly in between these 2 points. Similarly, L. Now I will draw capacitor in a vertical fashion. So I will write, sorry, I will write to C. Then the x coordinate will remain the same. Y coordinate will now become 0. Then back to origin. Let us now see the whole circuit. Yeah. So you can see one thing, when we do not have any component, we want to simply draw a wire, a short circuit. We will just give this to double hyphen and it will end here, right? So that is a simple thing. We can get our first circuit like this. These all are path type components. Now we have to label them. For example, the voltage source. Let us say the voltage source is Vs. How to label it? So inside the square bracket of the voltage source, in a comma separated fashion, I write L for level. It's a lowercase l. L equals, I will write say VL, sorry, VS. So within math mode, I write V underscore S and I run it. And yeah, this Vs comes here, source voltage. Similarly, I can label the resistance, I can label the inductance, and I can label the capacitance like this. Okay, so I get the RLC. In this way we can label it. That is one thing. Now suppose you do not want the Vs label to be on this side of this voltage source, you want it to be on the other side. What you have to do is, just before this equal sign, you have to put an underscore and it will go to the other side. Yeah, now it's on the other side. That way it will work. Okay, so labeling is complete. Now I want to show current, right? The current is, say I want to show current near this inductor. So current is I equals, let us say I want to write I and okay, IL, inductor current. The same thing here. So similarly, it was L for level, I for current. Current becomes equal to IL and I get the IL here. Now you see here IL is flowing towards right. Suppose you want to make the current flow in the opposite direction, you want to show a reverse direction. What you have to do is, just before this equal sign, you have to put an angular bracket in this way, so it is pointing towards left. Now you get the current in the other side. Now you might think that, what if the inductor was in a vertical fashion? Basically they have a default direction of current, and if you put this angular bracket, it changes the direction in that fashion. Now I get the current through an element. Now I want to show the voltage through the voltage across the capacitor. I will write V equals, sorry, V equals, within math mode I write say V underscore C. V underscore C. I get the voltage across a capacitor. Here there is a default polarity, you can see. Now if you want to change the polarity, same thing, you have to give an angular bracket here, and that will change the polarity. Okay, see, it has, the polarity has changed now. So this more or less completes the basic circuit drawing, path style components. One more thing, that is, suppose you want to put nodes. Although in this circuit we do not need any node, but let us still say you want to put node at two sides of the inductor. Or maybe we can draw another, say I draw another resistance here, from where this resistance ended. The resistance ended 5 5. Okay, so from 5 5, sorry, I draw another resistance and it will go to 5 0. right? Yeah. Now you see, I need a node here. I have to specify a node here to give a dot here, solid dot. How to do that? So what I need is I need dot across the two ends of this resistance. So for that, in the square bracket of the resistance, I will write in a comma separated fashion asterisk hyphen asterisk. So asterisk hyphen denotes the element, and asterisk here means dot on the both sides. So that will give dot on both the sides, here and here. Suppose you want dot at only this point, at only on the upper yeah, only on the upper point. So you put dot at one side, you will get dot at one side only, like this. Okay, so I put dot at both sides here. Yeah, it is also possible to change the color of the elements. I will just write comma red here, that will change the did not change. Okay, if red color equals red, then you will can get the red colored resistance here, right? And these things have also become red. Anyway, okay, let it be like this. So these are the path style components. Now one last thing is the ground. I want to put the ground, say here, this point I know this is 50. I want to draw the ground here. So I again the same thing, draw semicolon here, I will draw. Now you can understand that ground is not a path style component, right? It doesn't lie along a path, it just stays somewhere. So it is a node style component. So I will draw the ground here, 50. Now this is the basic structure of a node style component. You have to write node, square bracket, then parenthesis, then braces. This is the structure of a node style component. In the first, at the first the square bracket, I will write the name of the node, which is ground here. Here I will write the call sign of the node, that is in what name I shall call the node. But I do not need actually to call the node, so I can delete it. And in these braces will be the name that I want to show in the circuit, name of the node that I want to show in the circuit. Now you may not also give any name to this node, but these braces have to be here. These braces are mandatory. You can keep it vacant, but they are mandatory. Okay, so I run it and I get the ground here. Now let us say I want to, let me change the color, it's not looking very good. Now let us say I want to name this node as 0. Okay, so name this node as 0 means I'm not naming it, means I want to show 0 here. So for that what I have to do is I can simply write 0. So this 0 will show up in the circuit. But if you look at this doesn't look very good. It you can keep it like this. All and or there is another way to put it in a better way, that is write label equals, say I want to put it somewhere here, left side means west colon 0, and I run it. See, now it's in a better way, it's in a looks better. So that's how the circuit would look. So this thing more or less concludes our discussion about drawing circuit with path style components. The next thing that I will show is how to draw circuit in with node style elements. So for that I have to again write begin CircuiTikZ. Okay, so what I will draw is I will draw a integrator circuit using an op amp. Okay, now you can understand that op amp is a node style component, it does not lie along a path. So let us start. We start with the same thing, right? Draw, then at the origin let us say I put the op amp. again the same structure: node, square bracket first, then parenthesis, then braces. Okay, then how to draw an op amp? Op space amp, and I name this op amp as amp. Now see, this is the call sign of the op amp. In the code, in later stages, I will call the op amp. So this is its call sign. This amp will not appear in the circuit, and I this op1, this will appear in the circuit. This is its label, and this is its call sign. So you can see op amp is here, op1 its name, the label has appeared here, and amp is the call sign. Now try to understand the problem here. I have this op amp, but this is a node style component. I have put it at this 0 0, but I do not know where this 0 0 is. So I do not know what is the coordinate of this point, what is the coordinate of this point, what is the coordinate of this point. I do not know. So for that, there is a way to access these points, that is called anchor. All the nodes in CircuiTikZ, they have some anchors. For example, this op amp has 5 anchors, of which I will use 3 here. What are they? This inverting input, non-inverting input, and this output. What is this anchor called? This anchor is called minus. Okay, minus. That is the nomenclature of CircuiTikZ. That is not a engineering or science thing. That is the nomenclature of CircuiTikZ. So if I want to draw a line horizontally left from this point, I have to call this point. How to call this point? I am calling amp dot minus. See, amp was the call sign of the op amp, so amp dot minus indicates the not inverting terminal of the op amp, right? So from here I will go left by 1 point, let us say. So here is a short circuit, then by 1 point. Now another problem. The problem is I do not know the coordinate of this. So I do not know the coordinate of the point which is 1 point left to this point. Then how to get this point? Now comes the relative coordinate. Till now we have done everything in absolute coordinate in the previous example. Now we have to do in relative coordinate because we do not know the coordinates. So how to do relative coordinate? Relative coordinate defined like this: you have to put two plus signs that would denote the increment, then within the parenthesis you write the increment magnitude. So it is -1 comma 0, right? So this is the increment. How much increment? -1 comma 0, right? Now I want to go up by 2. Similarly I will write 0 comma 2 here. So with respect to this point, this is first I get my go to -1, then I go 2 2 up. Now let us see if we can do it in one stage. Here and here, if we can do it in one stage. So what I do is this increment itself I write as -1 comma 2. Okay, and I run it. But clearly it will join these 2 points with a straight line. Very straightforward. It will join these two in a straight line. But I do not want this. I want the line to first go horizontally, then go vertically. So I have to tell CircuiTikZ that you first go horizontally, then go vertically. How to tell that? I give a hyphen, then give this vertical dash. This means it will first go horizontally, then go vertically, so as to reach this point. The opposite is also possible. You can ask it to first go vertically, then go horizontally. Then it will look like this way. Now we do not want it here. Here we want it to first go horizontally, then go vertically. So here we are at this point. Now we will draw a capacitor and we'll join it here. Okay, let us name this point. We will need this point later. So if you want to access this point later, you have to name this point. How to name this point? Simply write coordinate, within parentheses you write the name. I have written A. Okay, now from here I will draw the capacitor. So 2C. Now the question is Where will the capacitor stop? It will start from here, but I want it to stop exactly above this output. Let me give some hypothesis, just some, mm, say I want to stop it after 3 in incremental fashion and see how it looks. We will better understand the problem here. Now I do not know this value. How much will this value be so that it exactly stops vertical to this point? How to know? Here is another thing that is very important. We will need it again and again if you draw circuits with circuitings, especially with node style components. So the point where the capacitor will stop, I can say that point is the intersection of two straight lines. Which two straight lines? A horizontal straight line drawn from A and a vertical straight line drawn from the output. So the point where it will stop is the intersection of those two straight lines. Now, how to tell circuitings that you stop there? This is a notation. So since I am now defining that exact point, intersection of those two straight lines, how to do that? First, I will write A. A is this point, right? Then I draw horizontal. Then I write this hyphen, means you draw horizontal from A and draw vertical from amp dot out. This is out. This anchor is out. So now this thing means, the thing is parenthesis. This thing means the point which is obtained by drawing horizontal from A and vertical from amp dot out, or in other words, y coordinate of A and x coordinate of amp dot out. So the C will go up to that point only. Let us see if it works. Yeah. See, now they have come in a vertical line. The rest part is straightforward. We can join it. AMP dot out. See, I named this op amp as AMP. That's why I am calling it AMP dot minus, AMP dot out, this way. Okay. Now the next part is resistance. As you know, in practical integrator, you need to connect a resistance here. Otherwise, this output saturates. So we have to draw a resistance. We have to start from this point. This point we named as A. So we will start from A. Again, the same structure, draw and semicolon. We start from A. Then we move upward by 2 points, let us say. So again, this relative movement, um, 0 2. Now we have reached this point from where the resistance will start. I name it, say, B. Then I write 2R. Again, where it will stop? We have already seen B, horizontal line from V, vertical line from from AMP dot out. We'll stop here. See if the resistance comes correctly. Yeah. Then we have to join. We can simply join it to the AMP dot out. We can simply join it to AMP dot out. Or you can also draw the line up to this point, but you will not understand that there are two lines here. It will look the same. Okay, so now from here we can understand that the capacitor needs node both the sides. So I will draw nodes. Capacitor needs nodes here. I got the nodes. Let me label L equals C and label L equals R. Okay, so these are done. Right, now we have one more. We have to get the V in. There will be a resistance here and the V in here, right? We did not name this point since we drew this continuously. We could have done a break, could have broken this path and named the point. But anyway, we know that it is actually -1 from this point. So We again start from amp dot minus. From there we go in a relative fashion minus 1 comma 0, and we come to this point. Now, sorry, now the resistance 2 r, let us also call this r, we can call it r1 r2 whatever, 2r, and let us say it goes for 2 points in the minus x direction. So this is how it will look. Right, now you see we need a node here, that is for sure. We give a node, and this will be a input, so we do not need a solid circle here, we need um, a hollow circle here. For that you have to write a o. Instead of asterisk I write o, lowercase o. So when I write a lowercase o, I get this thing. Okay, now this thing I will, at this point I will define a node. A node I will need, because I have to label this point as v in node. But what node? I do not need any exact node, I only just need to label it. So I write label equals the same fashion I showed in the last example west, and within math mode I write v in. This way it will come, right? Now similarly the output, at the output node also I will need the same thing. So I start from here, draw amp dot out. Here from I am starting, and I will go say 2 points or 1 point. I do not need to go 2 points, 1 point in the positive x direction, 1 point in the positive x direction here. Now you see in the previous case when I drew this resistance, I had opportunity to give these nodes, the solid node here, the hollow node here, in this way. But here there is no such element, there are only two double hyphens signifying short circuit. Then how do I give nodes here? So in such cases when you need to put option to a short circuit, you have to draw it in this way, to short. This will yield the same thing, you will get the same thing, same as the double hyphen. But now you have the opportunity to add nodes, asterisk hyphen o. Here you get asterisk hyphen o, right? So I think it's clear why I need to write this short here. Again the same thing, I will need to define this node. Mm, node is label equals east this time, east, and within math mode I need to write v out. You can notice here that I have to put these braces, although they are vacant I have to put them, they are mandatory. The parenthesis is optional, this parenthesis is optional, you can see I might not even given it, but these braces are not optional, they are mandatory even if you keep it vacant. Okay, almost done. The final thing is to draw the, is to short the non-inverting terminal with ground. So draw semicolon, within this I write non-inverting terminal is amp dot plus. From there, for symmetry, let me go minus 1 towards left. I have reached the point where I will put the ground, then I write the ground here and put the braces, that should do. But oh sorry, I did not write the minus 1 here, it went on the positive x-axis side. I did not run. Yeah, so that's all about it. This is how you draw. Now see, whatever you need to draw in however complex that circuit might be. Using these techniques, you can draw anything else, any other circuit that you will need. Let me show you some complicated circuits that I drew. This is another thing. Sorry, not here, might be. Okay, anyway, sorry, I lost them. Forget it. So now the most important part here is I did this with op-amp. Now you might need a transformer, you might need a MOSFET, you might need an IGBT in your circuit. How to know what to write here, how to call an IGBT here, how to know? First thing. Second thing is, even if I call an IGBT, how to know what are its anchors called? See, these things are called anchors. This is the minus, this is the plus, this is the out. How to know? For that you will need this book. So this is the um CircuiTikZ manual. These people, these four people are the people behind creating this beautiful package. So from here you have to simply say I want to use IGBT. Can I get IGBT? Let me see. Here you see. So the whatever you need, you search for it, and you will get the name of the node and the anchors. Whatever. Say you want transformer. See, this is a transformer. So this drawing will tell you what are the names of the anchors: a1, a2, inner dot a1, inner dot a2. Say if you want to put dot convention, what you have to do? If you want to put a dot convention, you have to just draw a solid node at this anchor. Okay, so that is where this book comes in. You need not learn from this book. You have to just use it for all these informations. That is why this book is important. This book is available for free. I have put a link in the description. You can download it from there. Right, we're almost done. One last thing is, suppose I want to make this circuit small. In my report or in my PPT, I want to put, PPT means I mean beamer obviously. I want to put, and this large circuit will not fit there, so I need to make it small. How to small it? Obvious, to make it small, obviously scale. Say I put scale equals 0.5. Okay, and then run it. You see, when I put the scale, the circuit definitely becomes smaller, but actually what it scales is the coordinates. The distances become scaled, the components do not get smaller, they are as large as they were. So to make the components also smaller, what you have to do, here within this bracket in a comma separated fashion, you have to write transform shape, then run it. Now you have a beautiful circuit. It's small, components are small, everything is small, and now you are good to go. You can use this circuit in your document. So that's how it is done. Use it. This is free. A very high resolution, very high resolution circuits you will get. Let me just show you. This is the circuits we just drew. Let me zoom in. Okay, we are at 6400% zoom. It will not break. Okay, this is called vector graphics, you might know. So that is why you should use this, especially if you are in LaTeX. So that's all. Thank you for watching.